Welcome again to this YouTube channel. So today our lesson is on how to formulate our first principle of differentiation. All right. So let's say I have this curve. Okay. So let's say my curve is y equals to fx, and then I have two point. Okay. You notice I have p and also I have Q. And let's say my P, okay, my point, my coordinate for my P is x1. And then my y, now I can say fx1 like this. Okay, and then I introduce my Q now. My Q is actually a coordinate of x2, and then I have another fx2. Okay, like this. All right. So you can see you have one point and another, and this point lies in the curve. Okay, it lies in the curve. Okay, it is not here, not here. Okay, it is in the curve. Okay, that's why it is very important. Why we are talking about in the curve? Because we want to see the curve. Curve is our fx. Okay, other than curve, we don't care at all. All right, so this PQ straight line we call a secant line. Okay, so this is your secant line. All right, so this is your secant line. Okay, now our intention, if let's say I want to see whatever happen if I want to move my Q. I want to move my Q goes as near as my P. Alright, so what does it mean by that? Meaning that if let's say my Q now change, okay, my Q change from this point, and then now this is my new Q. Okay, just imagine that this change like this. All right, so basically if my queue change into the new location, then my second line must also change into the new equation. Okay, I'm so sorry, the line is not that straight, but just imagine that it is straight. Okay, so the same thing happen if let's say you want to approach this. Okay, remember how you look at your limit. Okay, and then look whatever happened if you have a Q now reduce again. Okay, so your Q now goes into here, and you can imagine your okay, my second line now turns to here, and then my Q over here, and then my second line go so distracting. Okay, Q over here, and you can imagine it will go straight like this. Okay, so it's like this. Okay, so now let's look at the distance. Okay, distance between the second line travel, how the distance of the second line travel from one end to another end. Okay, let's see. We have the first one. Okay, imagine the first starting point of our second line. I put it in a little bit brighter like this one. So you see this is the distance for my fx, right? So my distance for my fx, okay, of course my distance, remember distance must be coming from your previous zero, isn't it? So my distance of this is actually this, because this is my fx2, right? And then this one must be my fx1. So my distance is just my fx1, my fx2 minus my fx1. All right. Okay. So I think you get that picture for the first distance. So actually this is your distance. Okay. And then whatever happen, if I want to look at the distance at the bottom part of it. All right. So this is my P, and that is my Q. So in that case, my distance over here now becomes, okay, you know this is your x2, and you know this is your x1. Okay, so my distance here is actually x2 minus x1. Okay, so you look at this one, you have two different distance put together. Okay, so my another question is, if let's say I want to find the slope of my secant line. All right, it's the slope. Okay, everyone knows slope is m. Okay, so secant line. All right, secant line meaning that my slope of P and Q. I know that if I have 2 points, I can use the coordinate value for these 2 points and transform it into a slope, right? Okay, so basically, you can look at this one. Sorry. You can look at this one. Your M is just your where is it? Okay, your M is just your f x2, all right, minus f x1 divided by x2 minus x1. Okay, so I think that one is clear, right? Okay, now this one is another step that we are going to make full use of. All right, okay, let's see whatever happened if my uh this one, if let's say my x2 minus x1, because I want to see the distance, right? I want to see the distance between this particular value x2 and also x1. And then to make things easier, I uh, I introduce another variables, okay, another constant, okay, h. For example, h represent the distance between my x2 and x1. Okay, doesn't matter whether your secant line is quite far away from each other, or your distance between your PQ is a little bit closer to each other. Okay, because x will change accordingly. X1 also will change accordingly. All right, so let's play along with this. And then my h now becomes, if let's say I want to improve my representation of my slope, okay, instead of having x2 and x1, now I want to reduce my x to become only one variable only. Okay, so in that case, whatever happen if I want to eliminate my x2, now my x2 only becomes x1 plus h. Okay, I hope that makes sense. Okay, this is just a simple transformation of your algebra. Okay, when you have x2 equals to x1 plus h, now you change all the value inside your x2 becomes like this. It is just the same, right? You just need to change your values over there. Okay, and then my x2 now becomes x1 plus h, but do not forget x1. All right, so basically once you have up until here, okay, you know now that, okay, I write again. Okay, you know your latest values now becomes f x1 plus h minus f x1, and then you simplify your denominator, you only have h. Okay, now your slope is just live with one variables only. H is just a constant, okay? H is just a value, okay? So the changes of variable is only x1 now. Instead of earlier, you have x1 and also x2. Okay, now we move forward to, okay, what is the point? Okay, what is the point of this thing? Okay, the point is, okay, let's say I want to find my uh, critical point. Okay, in this case, my point, my tangent point over here. What does it mean by tangent? Tangent meaning that this one, you only touch your curve in one point here in your curve. Okay, you have a curve, and then you have a very straight line, one tangent line. Okay, instead of earlier your P and Q, you have a secant line. Okay, secant line meaning that you have two different points in your curve, but now your point now becomes only one particular point. Okay, that is your objective. All right, so how you're going to move away your secant? Okay, you can see over here from my secant, from Q at the top, move forward to Q at the bottom, move forward at the Q at the another bottom, and Q at another bottom. You can imagine, okay, what about whatever happened to my H? As it move further down, okay, your H will reduce, okay, slowly, okay, because at first, your Q is in this form, and then the second one, okay, I make sure you understand this. It is getting smaller, all right, and then the second Q, see, it will reduce slowly, all right, and then you imagine as long as it goes down and down and down, okay, over here for example, it will reduce very very slightly, very very slightly, and you can see that now your H will go to uh your H will go to zero, right? Because your distance here, your distance over here now reduces until zero, okay, and you know when your H goes to zero, meaning that your distance is no longer there, but it's not zero, right? Because once it's zero, then you cannot say anything, but it goes very 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 close to zero, and then once it is goes very very close to zero, your second line now transform itself into a tangent line. Once that is happen, you can say that, oh, this is my first difference, my first principle of differentiation, all right, so meaning that I have this function, okay, but now I reduce my H, and I make sure that my H goes straight, almost goes to zero. Okay, so this is my tangent line, and you know tangent line is just a differentiation, or also the critical point where you have your value on your y. Okay, so basically this is what we call the first principle of differentiation. Interesting, isn't it? Okay, I'll see you guys in the next lesson where we are going to solve example using the first principle of differentiation. Okay, I hope you understand this particular lesson is a little bit harder, but if you carefully and slowly understand about the concept of secant line and also the tangent line, I believe you will have more understanding on this particular content. All right, so I'll see you guys in the next lesson. All the best.